So I can't remember if during the video I talked about crown ethers or not. And crown ethers are rings with alternating ethylene groups and oxygen. So it's a repeating unit of CH2CH2O, and then in a ring. And they're another good way of removing cations from solution. So they'll have similar effects on nucleophilic alkyl substitution reactions to the polar aprotic solvents, but they allow you to use a nonpolar solvent. Polar aprotic solvents have some disadvantages. They're water miscible and they're high boiling, so you can't just evaporate them off on the rotavap easily because of the boiling point. But since they're water miscible, they'll tend to drag your organic compound into your organic layer or your aqueous layer and mess up your extraction. So they're removing cations from solution to increase the reactivity of the anion. And because they've got those CH2CH2 groups, they are miscible with nonpolar solvents. So you can have the same effect that you would have with a polar aprotic solvent by using a crown ether in a nonpolar solvent like dichloromethane or something like that. So what they look like is that with repeating CH2 groups and oxygen. And this one's called 15 crown 5. The last number is the number of oxygens. And the first number is the number of atoms in the ring. So there are 15 atoms in the ring and 5 oxygens. And that perfectly fits sodium. Sodium fits nicely into that cavity. You have nice ion dipole interactions between the oxygen lone pairs and the sodium. So if you're using a sodium salt of your nucleophile, 15 crown 5 will put that sodium in the center. The other one that's commonly used is 18 crown 6. Right, so that's 18 total atoms and 6 oxygens. And that one is just the right size to fit potassium. So you can choose which ion you're removing from solution by choosing the right size cavity by selecting the correct crown ether. So 15 crown 5 will remove sodium from solution and 18 crown 6 will remove potassium from solution. And I don't think I covered that in the videos on solvent effects, which is where I usually cover it. So I figured I'd better talk about that now before you take the quiz. Are there any questions on that? The use of crown ethers. They're doing the same job as the polar aprotic solvents.